So we're going to have a look at sketching different types of graphs. So make sure you're aware of the shapes of the different common curves on page 28 of your notes and the top of page 29. So you need to recognise quadratics, cubics, reciprocals and exponentials. And again, you should be familiar with the majority of these from GCSE. So the one we're going to look at sketching here is y equals x squared minus x minus 2. So we know it's a quadratic to start with. We know it's a positive quadratic, so we should know that the shape is the general U shape. So positive quadratic looks like that. So it's a starting point. You need to know the general shape. So that once you've done the working out, you know if the shape's correct. Okay, to sketch a curve and to get the marks, what we need to know is where the cross and curve crosses the x-axis, so the roots of the equation. And we also need to know where it crosses the y-axis. When we move on in a few topics to differentiation, we'll be able to determine the point where the curve turns. So it's maximum or its minimum point. And again, that's something that we should put onto the curves once we've covered that topic, but it's something we'll go over in a later video and in past paper practice. Let's first determine where our curve crosses the x-axis. So you should remember from GCSE, we do this by setting the equation equal to 0. So it crosses the x-axis when y equals 0. So to do that, then let's set it equal to 0. X squared minus x minus 2 equals 0. Quadratic equation, solve it by factorising or quadratic formula, whatever way you want, but this one's straightforward. We get two answers, x equals minus 1 or x equals 2. So we know that the curve crosses the x-axis at the coordinates minus 1, 0 and minus 2, 0. Okay, before we sketch a curve, then the next thing we want to do is work out where it crosses the y-axis. So the curve will cut the y-axis whenever x equals 0. So replacing or substituting 0 in for x in our equation, we end up getting y to be minus 2. So another coordinate of the curve is 0, minus 2. So what we want to do is draw the general shape of the curve, making sure it goes through the points minus 1, 0, 2, 0 and 0, minus 2. Okay, so we don't know the exact turning point of this curve, and it's something that we could work out with our differentiation when we look at that later. So for now, we'll just draw the general shape of a positive quadratic with its roots and the coordinates where it crosses the y. Our second example then of sketching curves, you can see from this we have a cubic. If we were to expand it out, we would have an x cubed. However, I'm going to keep it factorised at the minute. So what we want to do is again find the roots of this equation, find the points where it crosses the x-axis. So we do that by letting y equal 0. So if y equals 0, we have x plus 2 upon x plus 5 upon x minus 3 equals 0. Solving that, then we let each bracket in turn equal 0 and get our solutions for x. So we end up getting x equal to minus 2, x equals minus 5 and x equals 3. So there are the 3 points where the cubic's cutting the x-axis. So the coordinates will be minus 2, 0, minus 5, 0 and 3, 0. So before we sketch our cubic, let's just have a look and find out where it crosses the y-axis. And so we do that by letting x equal 0. So in each of the brackets, we let x equal 0, so we're just left with a 2, a 5 and a minus 3. Multiplying that through then, 2 times 5 is 10, 10 times minus 3 gives us y equals minus 30. So it will cross the y-axis when x equals 0 and y is minus 30. So again, we know with a positive cubic, positive cubics, looking back at your notes for the general shape. Okay, and again, we could use differentiation to determine these coordinates, the maximum and the minimum turning points, but for now we're just going to sketch a general shape. So if we sketch a general shape of our cubic, okay, remember positive, get the shape right, it goes through minus 5, minus 2 and 3 on the x-axis and minus 30 on the y-axis. And again, turning points we would work out with differentiation, but for now the general shape is enough.